Okay, so this is the graph of the previous example. We know that we have horizontal asymptotes and vertical asymptotes. So my question to you is, are there any infinite limits? And the answer is yes. We have an infinite limit. Whenever we have a limit as x approaches a particular value, that could be either negative infinity or infinity. So this is the same idea as if I were asking you whether there are any vertical asymptotes or not. So vertical asymptotes and infinite limits and these limits from either the left or right of the right of a particular value are all related. If I ask you, are there any limits at infinity, your answer is yes, and the answer will be the same as if I were to ask you for horizontal asymptotes, because the limits are at infinity. That implies that the limit as x approaches infinity of f of x, and the limit as x approaches negative infinity of f of x. And you notice how these values actually have a numerical answer, and negative rad 2 over 3, and I'm not dealing with infinity or negative infinity as my answer. So these four things are equivalent as well. So in the book it's talking about infinite limits at infinity, and it seems that there are two words here that may mean the same. Hang on a sec. Okay, so this notation may seem a little bit confusing because now I have infinity in both sides. I have infinity as the answer, and I have infinity as the value that x is approaching to. So how does a function that have this feature look like? Well, it just simply means that as x grows very large, the y's grow very large. So it could be any function, for example, like this. If I have y equals x squared, as x grows very large, x squared grows very large, and there's no other way about it. The limit is infinity. So let me just give you an example for each so that you understand better how this works. So in here I have, as x approaches negative infinity, the y's go to infinity, so it implies that a function behaves like this. Well, it doesn't matter how it behaves on this side. It could be like this or like that. We could do anything. But as x grows very large negatively, the y is growing very large. So for every point in here, the x's are becoming more negative and the y's are becoming more positive. That's all it implies. So an example of this could be y equals negative x cubed. It could be one example. Or it could also be y equals x squared as well. An example for this kind of function that behaves this way, it could be, well, it could have anything here, but as x grows large, the y's are growing large negatively. So I have, for every point in here, the x's are still positive, but the y's become more and more negative. So anything that ends that way. And remember from pre-calc the end behavior of this function, if we were talking about polynomials, but it could be any function you want. And this one, naturally, it will be, I don't know what may happen on this side, but definitely on this side goes like that. Every point in here has an x that is negative and a y that is negative, and as I move this way infinitely, then it just becomes more negative on the x values and more negative on the y values.